Good evening, my dear students, and welcome to this session. How are you? Perfectly fine. Let me check. The session takes a little bit of time to initiate, so I'll make sure that the session has initiated, and then we are going to start with the topic today. Today's topic is extremely important. We are going to talk about the NCERT questions. See, there are certain things that need to be done to succeed in the NEET examination, and one of these things is to complete the NCERT questions. We are going to do as many questions as we can, and we are going to have the questions restricted for chemical equilibrium today. Just chemical equilibrium, nothing more, nothing less. And in that chemical equilibrium, I hope you'll be able to solve a lot of questions. So to begin over with these questions, could we just initiate it? Well, I believe you have your copies, pen, pencil, and all with you so that you can solve the question right along with me. Okay, we are not just going to tell you the question, we are going to solve the questions today, right now, here itself. Good evening, ready? So let's begin. Uh, Ananya, you had asked me a question, and that question is perfectly fine. What exactly is the problem in that question? You had asked me two questions. One, you asked me about the radioactive sugar. Please remember, whenever we talk about the saturated solution and we have an equilibrium established, then in that case, it's a dynamic equilibrium. Equilibrium, chemical equilibrium are all dynamic equilibrium. So that is perfectly fine. The answer was dynamic equilibrium. And when we talk about the degree of dissociation of 2Hi plus giving you H2 and I2, you can find that the left hand side and the right hand side have the same number of gaseous moles. When they have same number of gaseous moles, whatever be the degree of dissociation, the number of moles would remain the same as the reactant. Because whatever is the reactant consumed, exactly same amount of product is being formed. So whatever is the initial moles, the final moles also will remain the same. Is that clear, Ananya? That's what you had asked. Okay. जीते रहो बेटा अक्षय. Any confusions here? Perfect. So let's begin over with the NCERT questions. Okay. So are you ready with your paper and pencil? And remember, we are starting with the Elixir Droppers batch. Very soon this batch is going to start and you can use the code AVLive. Okay. And don't hesitate to ask a question right here in the chat box because we don't have many students, so we can individually answer the question. We can answer the questions of each individual student. I won't say that there is going to be a time waste because we are doing every and each and every student. Okay. So it has in-depth analysis of PYQs, revision classes, exam strategy, and now the cost of the course is 12,799. Only we are getting a special discount also. Now, Elixir dropper batch, which is going to start from 16th of August. Botany is going to from 6:30 to 7:30. Chemistry from 7:30 to 9. Be very clear, chemistry's session is going to be of 90 minutes. Zoology is 9 to 10, and physics again is of 90 minutes. That is 12 to 1:30 p.m. And that's with Archana ma'am. Okay, so you start from 12 p.m. that is afternoon, and you go on till night 10 p.m. And lot many sessions in between. That is botany 2 p.m. Swati Batra ma'am, 3 p.m. zoology with Dr. Sachin Kapur, 4 p.m. with me chemistry, and 9:30 p.m. we have physics with Archana ma'am. Is it clear? That's me. MSc in chemistry for 26 years of experience, and lakhs of students have been taught by me. Elixir dropper batch for NEET 2024. That is what we have already talked about, 15,999, and you can use the code AVLIVE to get the extra benefit. Clear? So let's start with subjective questions of chemical equilibrium. So are we starting with it? So when you talk about this question, are you attempting it? So I'm going to give you a hint and then you have to give me the answer. Now this is a solved question of NCERT. So should I give you the hint again? It is a solved question, isn't it? You have done it. Equilibrium constant. K equilibrium is equal to the product of the concentration of the products. Now here the equation you have to write. Don't ever dare to not write the equation. N2 plus 3H2 in equilibrium with 2NH3. Fine. So here we're going to talk. If you don't write the equation, then in that case, whether your answer is right or wrong, it will be considered wrong because I can write any equation. And with the equation, you understand that the equilibrium constant value does change. So here we talk about K equilibrium is going to be NH3 concentration raised to power 2 divided by concentration of N2 into concentration of H2 raised to power 3, and that becomes equal to the concentration of NH3 is 1.2 into 10 raised to power minus 2 raised to power 2 divided by the concentration of N2, that is 1.5 into 10 raised to power minus 2 raised to power 1 into 3 into 10 raised to power minus 2 raised to power 3. Is this clear? So here you can calculate. I believe somebody told me that the NCERT, the answer given is wrong. The calculation comes out to be 0.53 and the answer given is 1.06. Isn't it? Something wrong with the answer. Okay, so any problems with this question? Okay, let's get along with the next question. At equilibrium concentration of N2, O2, and NO in a sealed vessel at 800 Kelvin, what will be the Kc for the reaction? Concentration are again given and Kc is asked. Okay. The important thing is in these two in this reaction, Kc and Kp will come out to be the same. Here, delta Ng is equal to 0. We have 2 moles of the gases in the product, and we have 2 moles of the gases in the reactant. So delta Ng will turn out to be 0. And when delta Ng is 0, then Kp is equal to Kc. Any confusions, anybody? Anyone who has not liked the session, go ahead and like it. देखो अगर मैं फास्ट जाने लगूं तो बता देना. पता नहीं चल पा रहा ना, यही तो प्रॉब्लम होती है ऑनलाइन और ऑफलाइन की. I'm not able to see you, so I'm not able to check it out whether you have completed the question or not. PCl5, PCl3, and Cl2 are at equilibrium at 5 at 100 Kelvin and are having the concentration 1.59, 1.59, 1.41 Kc for the reaction. Should not be a problem. Okay. Here Kp is not equal to Kc. Delta Ng is 1. Simple? Great. This question, done? Clear? Yeah, temperature is given. But is it required? Okay, fine. Do we need the temperature? I don't think so we need the temperature. Everything given in the question is not to be used. It's going to be simple. It's going to be CO2 concentration. If only CO and H2O are present initially, so that means the reaction has to go in the forward direction. So what we need to say is CO plus H2O is in equilibrium with CO2 plus H2. Now here it is 0.1, here it is 0.1 initially. Here it is 0, here it is 0 initially. Now what we can say is 0.1 minus X. I'm not talking about alpha, I'm not talking about degree of dissociation. Let's say I take it as X. So this is going to be 0.1 minus X. As both of them have the same stoichiometric coefficient, whatever amount of CO is going to be consumed, same amount of H2O also will be consumed. Now, if X amount of CO is consumed, CO2 formed is X amount, H2 formed is X amount. So the equilibrium constant is actually equal to X into X divided by 0.1 minus X whole raised to power 2. That is equal to 4.24. Is it clear? So I can simply say, see, either we can make the quadratic equation and get the two roots, or you can simply square root it, and you are going to get X upon 0.1 minus X is equal to under root of 4.24. 4.24, is it 2.2 under root of 4.24? Why do we need to say reversible reaction? Ananya? We are doing the equilibrium chapter. Each and every reaction is reversible. That is the condition of equilibrium. So we don't mention that this reaction is reversible because it's absolutely understood. We are talking about equilibrium. Is it clear? Yes, Ananya. Reactant is decreasing and we had only the reactant. Here we did not have to find the value of Q to understand whether the reaction is going to go in the forward or the backward direction because product was not given. Okay, since product concentration is 0, the value of Q has to be less than K. Numerator is 0 and denominator is not 0. Is this clear? Now we need the temperature. Here we need the temperature. And we need delta Ng. Okay, because Kp is equal to Kc multiplied by RT raised to power delta Ng. Temperature is given to you. R value is going to be 0.0831 because we are talking about in bar. What happened here? Just a minute. Okay, there was a little bit, थोड़ा सा गड़बड़ हुई थी. Okay, a little bit of connection issues. So Kp is equal to Kc RT raised to power delta Ng. So that is what we have as the reaction. कोई clear? कोई दिक्कत तो नहीं है? T की वैल्यू आपको दे रखी है, R की वैल्यू आपको पता है. R value is going to be taken as 0.0831. And why is it taken as? Because it's in bar. Clear? Bar decimeter cube per mole per Kelvin. Okay, fine. Let's have the next one. The value of Kp for the reaction is 3 at this. If initially PCO2 is 0.48 bar and PCO is 0 bar and pure graphite is present, calculate the equilibrium partial pressure of CO and CO2. Now we have CO2. Carbon is solid. In equilibrium with 2CO, gaseous. Clear? CO2 partial pressure is given as 0.48 bar. It is 0.48 bar. And pure graphite is present. So this partial pressure of pure graphite is equal to 0. And here 2CO, this has been given as 0. Now let us consider that 0.48, let us say a small amount of it is getting dissociated. That's what we find. It's P amount. Now here 2P amount will be formed. And if we talk about the Kp will be equal to the partial pressure of CO raised to power 2 divided by the partial pressure of CO2. And that would be equal to 2P raised to power 2 divided by 0.48 minus P, and that's equal to 3. Will you be able to solve it now? Okay. Now, the value of Kc for the reaction is given. Now, here is the reaction mixture. Now, how are you going to do it? Here you will need to find out the value of Q, and you have to find the value of K. The Kc is given to you. Now you need to find out the Q. Q value is going to be actually here A, B, C. So it is going to be A, B upon C, and that is equal to 1. The value of Q is 1. Here the concentrations are equal. The reaction is not at equilibrium. Can you see that? The equilibrium does not mean equal. It means unchanging. Okay. Now Q is greater than K. K की value है 2 into 10 to the power minus 3. Q की value है 1. So reaction would be going backward. Any problems, anybody here? Now, let's see this question. 13.8 grams. Be very clear, this question actually has more calculations. Why does it have more calculation? Because you will have to convert it into moles. You cannot take mass, you have to convert it into moles. Because if you're talking about physical equilibrium or the phase equilibrium, mass would have worked because left hand side and right hand side, there would be the same number of moles or maybe same substance. So here the mass would have been working. But in this case, the mass will not work. You will have to have moles. Will you be able to do it? Remember, you are not supposed to deal in mass. You are supposed to deal in moles. And when you have the moles, you can actually get the partial pressure also. So here you have been given a total pressure. So what you can do is you can find the Kc, you can find the K in terms of moles fraction, and then you can find out the Kp. Is this clear? Here using 1.38, you are going to find the partial pressure of N2O4, initial partial pressure of N2O4. Let us say we have N2O4 in equilibrium with the 2NO2. Okay, here we can use the degree of dissociation because we have only one reactant. So let's say initial partial pressure of N2O4 is PN2O4. PN24 1 minus alpha will be in equilibrium with twice of PN2O4 alpha. Okay. If you have found this initial partial pressure, then you can find this pressure, this total pressure, and you will be able to find the alpha here. Is this clear? Will you be able to do it? And this is a solved question in NCERT. A simple question, isn't it? So, what's the composition of the mixture at equilibrium? Any difficulty? We have 3 moles of PCl5 kept in 1 liter closed reaction vessel. So concentration also is 3 moles per liter. That is 3 molar. Kc value is given to you. At equilibrium, it's going to be, yeah, initial concentration of PCl3 is 0. Initial concentration of PCl3 is 0. They are not asking you the initial concentration, yet they are asking you the concentration at equilibrium. So 3 alpha into 3 alpha divided by 3 into 1 minus alpha. You can take, you can actually have the concentration minus 3 minus x also. But I would suggest that you use the dissociation constant, degree of dissociation. And that's equal to 1.8. Find the value of alpha, and you are going to get the concentration of each of these species. Okay? I think we have everybody we know delta G naught is equal to minus 2.303 RT log K. Yes, Ananya, you have to do it in moles. And here moles and molarity will turn out to be the same because volume is 1 liter. Is that clear? I think we can calculate the delta G naught. Again, the same question here. Okay, now please tell me the answers. Now these are the unsolved questions of the chap and the book. Ananya, actually ln is difficult to calculate because we don't have the table for ln. We don't use the table for ln. So it will be better if we talk about minus 2.303 RT log K. Log is to the base 10. Okay. Initial effect suddenly increased. Initial effect is decreases. How do rates of evaporation and condensation change initially? Rate of evaporation remains same. We have not changed the temperature. Rate of condensation decreases. What happens when equilibrium is restored finally, and what will be the final vapor pressure? Same. Is that clear? Any confusions? Check it out. And you have to talk about the equilibrium equation. We have already done this equation. Clear? At a certain temperature and total pressure of 10 raised to power 5 Pascal, 10 raised to power 5 Pascal is 1 bar. So, how are you going to calculate it? Are you going to calculate the equilibrium constant in Pascal, or you are going to calculate it in bar? If you calculate it in bar, then in that case, it's going to be just simply 1 bar. Now, when we say that iodine vapor contains 40% by volume of iodine atom, 40%. So that means we have I2 gaseous in equilibrium with 2I gaseous. This is going to be 0.6 and this is 0.4. When you talk about 40% by volume, it becomes 40% by pressure as well, and it becomes 40% by moles as well. Clear? Now you can solve it. It should not be any problem. If you take it in bar, it's going to be 0.4 raised to power 2 divided by 0.6. If you take it in pascals, then in that case, it's going to be 0.4 into 10 raised to power minus 10 raised to power 5 raised to power 2 divided by 0.6 into 10 raised to power 5. Kc depends only on temperature. Yes, Kc depends only on temperature. Kc, Kp, they depend on temperature, and Kc, Kp do not depend on pressure. They do not depend on concentration. Okay. Now here I believe you can give the expression of equilibrium constant for each of the following. Any doubts with that? Quickly write in your books, in your copies. 'Any confusions with any of these options? वन बाय एफ ई रेस टू आर लास्ट वाला इक्वेशन में एफ ई F2. Yeah, this is solid. It is actually going to be 1 by F2 raised to power 5. Yes, it will be 1 by F2 raised to power 5. I think we can find out the Kc from Kp. Okay. Now, one thing more. I told you one thing that whenever we talk about equilibrium equation, these represent the elementary reactions. Now, that was not mentioned in any of the questions, but here they are mentioning it that the reverse reaction in the equilibrium are elementary bimolecular reactions. So they have mentioned it. There was no need to mention it because it's understood if they are in equilibrium, they have to be elementary reactions. Equilibrium equation represents elementary reaction, but they have mentioned it here specifically. Just to confuse you, what was very well known, they have just mentioned it, nothing more than that. Is that clear? Now, can anybody give me the answer here? I have given you the answer. Can you write the answer now? याद है? Because pure liquids and solids, the concentration remains a constant throughout the reaction, and that's why it can be ignored because it remains a constant. Okay, so this remains a constant. That is why we ignore the pure liquids and solids while writing the equilibrium constant expression. Is that clear? Okay. Reaction between N2 and O2 takes place as follows. 2N2 plus O2 gives you 2N2O. Now here, एक बात का ध्यान रखो please. We have 2N2 plus O2 is in equilibrium with 2N2O. Okay. Now here, the initial concentration of N2 is 0.482 and O2 is 0.933. And it's a 10-liter reaction vessel, so divided by 10, that is going to be the concentration. Okay. And allowed to form N2O at a temperature for which Kc is equal to 2 into 10 to the power minus 37. So what we'll find is that, let us say here, some amount of N2, let us say X amount of N2 is consumed. So X by 2 amount of O2 will be consumed and X amount of N2O will be formed. Anybody has a confusion here? Or rather than putting X, you can put 2X. Your wish, your wish. You can put 2X, but you need to remember that you have taken it 2X instead of X. Okay, so or you can write it just like sometimes 0.482 by 10 minus 2X. 0.933 by 10 minus X, and here it is going to be 2X. Clear? Now Kc, the value is going to be N2O raised to power 2. Concentration of N2O raised to power 2 divided by the concentration of N2 raised to power 2 into concentration of O2 raised to power 1, and that's equal to 2 into 10 raised to power minus 37. What does this mean? This means that the product concentration is extremely low. Extremely low. So actually, this part can be neglected. These parts can be neglected. So here the Kc would actually turn out to be the concentration of N2O, whether let's say I take it as x square upon. This is going to be 0.0482 raised to power 2 into 0.90933. Okay. This x or x by 2 or 2x, whatever it is neglected in comparison to the initial concentration of the reactant because the reaction has a very low value of equilibrium constant. ये बात समझ में आई? Is it clear? So here if you put x, you are really going to get confused because this value is going to be extremely small. And please remember, not a question of equilibrium. ये इक्विलिब्रियम चैप्टर का क्वेश्चन ही नहीं है. इट्स द क्वेश्चन ऑफ स्टोइकियोमेट्री. ठीक है. इट्स सिंपल क्वेश्चन ऑफ स्टोइकियोमेट्री. इसे इक्विलिब्रियम से करने की कोशिश मत करना, सीधा सीधा स्टोइकियोमेट्री से हो जाएगा. इससे इतना मिलता है, इससे इतना मिला, बात खत्म. Any confusions? Kp is given, Kc needs to be found. And here they have mentioned bar for the simple reason that they want you to know what the value of R should be used. Okay, to be using the value of R. Okay. So here we have, this is 0.2. This is initially 0 and 0. Now 0.2 minus 2x कर दें या फिर 2p कर दें. That gives us 2x, 2x. नहीं. That gives us x and x. Okay. Now 0.2 minus 2x is equal to 0.04. I think we can find out the value of x. X is equal to 0.08. So here it's going to be, here it is 0.04, this is 0.08, this is 0.08. I think we can find out Kp. For this particular reaction, Kp and Kc are going to be the same. Why writing is 2 into 10 raised to the power 10? I would sincerely request you to do all these questions. I know this is going to take time. It is going to be difficult. It's going to be boring, irritating. But if you do it, you will not have a problem in the equilibrium chapter again. ओके, इस वाले का आंसर दो। Anyone has any problem with this particular question? ये चैप्टर बोरिंग लगता था, अब नहीं लगता। अब नहीं लगता तो दैट्स अ ग्रेट अचीवमेंट। आज शाम को 7 बजे we have a class in the special classes where we are going to do the questions of equilibrium, the objective questions of equilibrium, chemical equilibrium. ये वाला बताना है क्यों? You have to find the value of q. q की वैल्यू निकालो, पता चल जाएगा कि रिएक्शन फॉरवर्ड जाएगा या बैकवर्ड जाएगा। ये अक्षय, इस क्वेश्चन में क्या करना है? यू हैव टू जस्ट फाइंड द वैल्यू ऑफ q. q इज इक्वल टू द concentration of NH3 raised to power 2 divided by the concentration of N2 into concentration of H2 raised to power 3. Just put the values, get the answer. And please remember, here is going to be concentration is 1.57 divided by 20. Don't forget it. If you forget this divided by 20, you are going to get a wrong answer. We want concentration, not the moles. Okay? The equilibrium constant expression for the gas reaction is this, right? The balanced chemical equation. लिख सकते हो इसकी equation, जल्दी लिख के दो. I think it's quite easy. बहुत simple सा है. 4NO plus 5H2O in equilibrium with 4NH3 plus 5O2. कोई problem? Check it out this question. 5H2O की जगह 6 नहीं होगा बेटा? ओ, होना तो शायद 6 ही चाहिए। हाँ, यहाँ पे ये गलती है। दिस इज मिस्टेक, दिस शुड बी 6। Any problem with this question? Any confusions here? We are starting with HI. The reaction is going to go in the backward direction. But please, please, please don't reverse the reaction. Let the reaction be as it is. Unit dimensions. This is going to be a dimensionless value, isn't it? किसका यूनिट पूछ रहा है अनन्या? यहाँ पे even if you don't use the standard value, delta ng is zero. If delta ng is zero, then in that case the value is going to be dimensionless. इसमें क्या सोचना है dimensions के बारे में? Is it clear? Again, the same thing. हो गया ये? कोई प्रॉब्लम? I think we are having the similar kind of questions now. Himesh Jagtap, welcome. The patterns are the same, the questions are similar, but you need to do them to get the right answer. Slight differences would be there in the questions. Sometimes you will have to get the Kp from Kc, sometimes you have to get the product from the reactant, sometimes reactant from the product. Okay, sometimes the question has the same moles on the left and the right hand side. In this case, there are different moles on the left and the right hand side. Any problems here in this question? As you can see, in 1 hour, we have finished off a lot of questions, isn't it? Well, check out this question. इसमें quadratic equation? I don't think so. Linear equation से हो जाएगा क्योंकि left hand side and right hand side have the same stoichiometric coefficients. And we just have to find the k. Okay? That's very great, Ananya. So if physics can help through chemistry, that is going to be beneficial to you. लास्ट में क्या हुआ अक्षर? लास्ट वाले क्वेश्चन में कौन से क्वेश्चन में? इसकी बात कर रहे हो? अरे लास्ट क्वेश्चन कंप्लीटली विजिबल नहीं है, आपकी बुक में तो विजिबल है. 7.17. हाँ, इसमें क्वाड्रेटिक लगेगी. Is it clear? Remember here K, P is equal to partial pressure of CO2 divided by partial pressure of CO. Okay. Will you be able to do the rest of the questions? So prepare for the session at 7 p.m. 7 p.m. we are going to do the questions of equilibrium chapter. काफी सारे क्वेश्चंस हैं. I'll just put this particular file on the WhatsApp group and the Telegram group. So you can download it and attempt the questions. Well, वैसे तो NCERT के और एग्जाम्पलर के क्वेश्चन नहीं क्या करना डाल के. You can do it from NCERT and exampler. Okay. So NEET dropper batch for NEET UG 2024 subscription. Use the code AVLIVE and join with it. Okay. मिलते हैं शाम को 7 बजे. क्लियर. बॉन्डिंग वाले क्वेश्चंस भी करने हैं. अब तुम्हारे पास क्वेश्चंस की कोई कमी नहीं है, काम की कमी नहीं है बेटा. ठीक है. And I'm not going to give you extra work. I'm going to give only which is necessary. I could have given you thousands of question of bonding. I'm giving you just 50. ठीक है. Bye bye. मिलते हैं 7 p.m. in the special class. Okay. Till then, take care. Bye bye.